Hi, my name is René Schickbauer, but many people call me Kevek on the internet. I've been running solar projects in my garden for a number of years in the course of the Garden Space Program. Wait, you don't know what that is? Let's roll the trailer.
The garden, on the most popular island that does not exist. Welcome to the Null Island Space Agency, where we learn about doing space missions without space and without any budget. But at least it's open source. Let's call it the Garden Space Program.
After doing solar projects in my garden for a number of years, I want to share what I learned, how it works, so you can do it in your own projects. And at the end of the talk, I'm gonna release some hardware you can use as your basis or inspiration for your own projects. Okay, let's take a look at which general components a solar system has so you can run your own projects. First, of course, you have some solar panels. Then what you need is some sort of charge controller, because the voltages of a solar panel fluctuate during the day and you don't have any power during the night. So we have a charge controller. We need some batteries. And we need your electronics. Some sort of, Arduino, for example. And depending on which type of battery you have, you might also need some sort of battery management system, BMS, which is between the charge controller and the battery. It's important to understand that those components are all interdependent. You need to size the solar panels depending on your battery and your load, and you can you have to tweak your load so you can run it off your system. The charge controller needs to be sized to those components. Battery management needs to be sized for this component. So let's take it one step at a time. The first thing we're gonna look at is the battery, because that's really the heart of the system. And the battery size really depends on your load. You need to figure out how much power you're gonna use, and then size the battery so the project can run overnight with some extras. You might have days where you can't charge because of bad weather or snow or whatever, and my rule of thumb is I want to run my electronics purely on battery for at least 7 days, because if there's snow on the panel, then you might have a week or so before you can clean it off or the snow melts. You have multiple types of batteries to choose from. The most common is lead acid. Then you have nickel metal hydride, which is very often used in those small solar lights you get for a few euros. Then you have lithium ion, which is, you know, the explodey kind of batteries. Then you have the LiPo batteries, which are used in drones and so. And then you have a special type of lithium battery, LiPo4, which is a more stable kind. In theory, you can use other battery types like the cadmium batteries. They are now sort of illegal as far as I know, but they were used in some small solar projects many decades ago, and they're proved to be very stable. So if you can get them, you can experiment with them. Let's take a look at those battery types and look a bit at the pros and cons of them. Let's start by excluding some. Lithium ion is, well, it has a big capacity for its size, but it has quite a few problems. With all those lithium types, you need a battery management system that can get complicated and sort of expensive. But lithium ion is very unstable when it comes to temperature. If it gets too hot, it explodes. If it freezes and you try to charge it, it might explode when it gets warmer. So I tend to not use it because it's just too much of a hassle, and frankly I don't want to plant small bombs all over my garden, so there's that. Lithium polymer has the same problem, plus it's even a bit more demanding than lithium ion and is even worse when you accidentally discharge it too far. And yeah, LiPo4 is more and more upcoming in the market to replace lead acid and stuff, but it's very, very expensive compared to other battery types. So you can look into it, but for my part, I decided against using that kind of technology at the moment because it's just too expensive for hobby projects. This LiPo4 is it's worth if you need something that's relatively lightweight compared to other battery types for the same capacity, but if you just plonk it down in your garden, it doesn't really matter how much it weighs. The postal worker might complain because he just has to deliver a 20 kilo battery, but frankly that's not your problem. So nickel metal hydride is good for very small, very low demanding electronics, but it also has, well, if you need more capacity, that's way too expensive, and it also doesn't really work when it gets too cold. So let's look at lead acid battery. It's very easy to use. It's, of course, you might say, Why, it has lead in it, so it must be dangerous. But frankly, lead acid batteries have been used for over 100 years now. They're in every car. The batteries are very easy to recycle, and your charging circuit can be as simple as it can get with any battery technology. It's lead acid is basically for solar. It looks like a car battery, but the plates are thicker and some small details, but basically think of a much better car battery. You know, the box with the two terminals. It's very stable at pretty much all temperatures that humans can survive at, so that's a bonus. It's relatively maintenance free. It's, as I said, easy to charge and discharge, and this is also the battery type for which most pre-made solar charge controllers are designed for. So the charge controllers are also cheaper, and the battery itself per kilowatt hour per unit of energy, lead acid is pretty much the cheapest technology you can find, and it's very reliable over a number of years. Next, let's look at solar panels. They're pretty easy to understand, the basic. The two informations you need about them is the max voltage and the optimum voltage for taking out power. I explain that more when we come to the charge controller. And yeah, then you have the watt rating. Let's say you have a panel of 100 watt. You might say, oh great, I get 100 watts out of it. No, not likely. The rating is basically if you're on the perfect day on the equator and the solar panel points exactly in the direction of the sun, then you get 100 watt out if your charge controller uses the optimum voltage, basically. So in summer you can say, I always say, okay, you can have tracking panels that move and always point at the sun, but those are expensive, they're complicated, they need maintenance, so a fixed installation is usually the best compromise, especially since solar panels get cheaper all the time, and it's just easier to buy one more solar panel than to buy a tracking solution that's probably cost 10 times like what the solar panel costs. So in summer you might get out during noon, you might get out like 80 watts, and in winter on bad weather you might get out like 5 to 10 watts. And that's the number you're usually working with. And depending on the length of the day and the angle of the sun, you might get that out for 1 hour, 2 hours, maybe 6 hours in summer. It really depends on your location. But for sizing the system, you always want to use the lowest number. So let's say your location is not optimal because you live somewhere where there's mountains or there's some trees or whatever. Let's say you get 5 watts for 2 hours. That means you get 10 watt hours. And then you have some losses, so in the battery you might only get 8 watt hours, and that's your energy budget. Of course, then you have to work out, you want a reserve, so not every day charges, so you might have to size your panels and your electronics to run on, like, say 1 or 2 watt hours a day, which is completely achievable. It's even for complicated radio controlled projects, you can do it. I'll show you later. The next step in designing your solar system is selecting a charge controller. First, you need to know the type of battery you're using, because you need a battery controller, a charge controller that supports that. Lead acid, as I said, is the most common type currently, so most charge controllers you'll find online are lead acid type charge controllers. Then you need to know the maximum rating of your solar panels in terms of volts and amps. Most charge controllers, or at least the better ones, will support panels that deliver more amps than their rating. They just don't take the power, but some of the cheap charge controllers will just go up in flames. Let's say you have a solar panel that at maximum, and this is one of the times you really need to use the maximum rating, that will deliver up to say 100 watts at 20 volts. So you have a maximum rating of, say, 5 amps, but depending on the charge controller and the voltage, you want to size it for 10 amps. So let's say that's our budget, and you really need to check the data sheet of the charge controller that it really supports that, and what happens if the solar panels would deliver more ampere. If it really just, either it says, okay, I will only charge at 10 amps no matter how much power you deliver, or it will say never ever put more power in, and you want the one that just doesn't care and just doesn't burn out if you accidentally deliver more power. And the other thing you want to know is you have two types of charge controller. You have PWM and you have MPPT. That's pulse width modulation. So basically the controller, if we look at the power delivered to the battery, we'll just turn it off and on and off and on and off, and that works to a certain extent. Those charge controllers are usually very, very, very cheap, but please don't buy them. They're junk. I mean, yes, they work to some extent, but what you really want is maximum power point tracking charge controllers. They will try to maximize the amount of power they get out of the solar panels. And that's what I mentioned here with the, let's say, where do I have that? Okay. Find it. The optimum voltage of the solar panel. That's not the maximum voltage, but you pull a certain power, the voltage drops, and at some point, if you look at the voltage of the panel, if you say you pull more power, the voltage drops, and the current, the ampere, rises, and at some point you get the maximum power out, and that's what an MPPT charge controller does. Think of it as black electronic magic, but it just works. You get more efficiency, and what's more important, on days where you don't have direct sunlight, it often works better because because it just does. I could go into the details, but then we have a 10-hour lecture on this. And one other thing for the charge controller you want to look at is connectivity. Many charge controllers have some sort of display, but that's usually useless unless you stand in front of it and read the values. What you really want to do is interface where you can read out the data automatically, and usually it's Modbus. And this really helps you log the data and see how you can improve your system. There is one more thing you might need to know when you have multiple solar panels, and that is you can hook them up in series or in parallel. If you hook them up in series, especially with the cheaply available commercial panels, basically you have those panels and your charge controller. You have one wire here, 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 and then you go there. That's the setup That's probably in the manual of your charge controller, but you really have to keep on an eye on the maximum voltage of the system. And it has a problem if, let's say, this solar panel is shaded, then the whole voltage drops and it really gets inefficient. And even a partial shading, because like it's autumn and there are leaves on the panel, can have very bad effect on the efficiency of the panels. The other way is, let's flip this over. The other way is to hook them up in parallel, and that has also the benefit that you can use slightly different panels, especially if you build them on your own. That's a real benefit. And if one is shaded, then that one doesn't produce power, or not as much, but it works much more efficient, especially for smaller systems. And basically you have your panels here. One side is common, that goes to the charge controller, and then you add some protection diodes, and put that on a common bus. And so if one panel fails, everything else works. If one is shaded, then the other still produce their maximum power they can with the sunlight. Okay, let's take a look at the electronics. You have basically two types you can use. You can use something that's Arduino based, or you have those ESP32 thingy magics. I use them some, but I'm not really happy about how they work. And then you have Arduinos. They work, but their biggest problems is their voltage converter. Let me explain. If you have a 12 volt lead acid battery, that doesn't mean you get 12 volt out of it. Depending on the charge state, you might get from about 11 volts to up to 15 volts. Those things can't handle 15 volts very well. As I had some burnout, some work very inefficiently. They have linear regulators. You really want to avoid those. Linear regulators are basically a big resistor, and then your Arduino, and then the terminals to the battery, right? And they say you need 5 volt here, you got 15 volt here, and the rest of the energy basically gets out as heat. That's bad, that's inefficient, and if you put in 15 volts, it will desolder itself, depending on exactly which manufacturer and which version of Arduino you get. And the other problem with standard Arduinos is also very dependent on the manufacturer and which version and which, depending on the 3.3 volts regulator on this is usually junk. It works exactly enough to run the Uno itself, but as soon as you put some load on it, it just doesn't work anymore usually. So but I like the idea of them, but the other problem with using a standard Arduino or those things for that matter is besides the crappy voltage regulation, they have a lot of stuff on board that you really don't need in the field, and that just sucks power, like a USB chip and LEDs. If this thing is out in the field in a box, you don't need a power LED, you don't need USB, and both of these, you can't really update them in the field. There's some ways around it, but yeah, it's a pain in the seating arrangement. That's why I come up with, let me grab it, this. This is a Radiodna. You can find all the information on this link here, and it has a lot of features these things just don't. It has proper power regulation. It works up to 40 volts, from 7 to 40 volts. You basically, if you don't need it to work at night, you can just hook up the solar panel and you're done. It has NRF 24 radio communication. It's basically the same band as 2.4 gigahertz Wi-Fi, but it's a narrowband thing which has a range of this module, I think, 1.5 kilometers if you have line of sight, and like 100 meters if you don't, depending exactly on your circumstances. It has an onboard real-time clock that works even if you take power away. It has various power-saving features. It has mod boost to talk to controllers like this and to daughter boards. And it has onboard 256 kilobyte onboard EEPROM to store data. No SD card at the moment because I found them unreliable, especially mechanically. If this is outside for like a year or something and it warms up and it cools down, then the SD card has a tendency to just work its way loose, and then you have to go out and fix it and whatever. It has FRAM, which is ferromagnetic RAM, something which keeps its memory even if you power off and power on, and it has practically infinite write cycles. And yeah, this is a hardware I'm releasing open source. There's software, there's hardware for this. I'm still working on it, and as soon as I finish the new bootloader, you have the option of sending a new Arduino image through NRF 24, and tell it to flash the new image to the processor. So it's fully OTA compatible, and the software libraries are pretty much standard, except for a few bug fixes I have to make. And the idea is, this is a base system, and you plug in smart boards that have their own processor. The Radiodna itself does all the power management. It can go to deep sleep, where it only uses about 8 milliampere at 10 volts. So it's 0.08 watts, which means it can run a really long time on even a small lead acid battery, and you only need like once a week recharging, if that at all. I'm currently working on a few smart boards for this. One is an intelligent power distribution system. So you have 8 channels you can switch. I'm working on H-bridge modules, so you can control motors. I'm working on a servo module where you can control servos. I'm working on a stepper motor control module where you can control stepper motors, so for all your robotics needs. And I also have a prototype of, let me move this. This is a very ugly prototype for an inverter module, a low power inverter that can generate 240 volts with the help of some transformers so you can transmit power from your solar system over longer distances. And every one of those modules can be radio controlled or automated, or both, with the help of the base Radiodna. And every one of those modules can either be plugged in as like an Arduino shield, or can be mounted somewhere else and controlled with a Modbus. And this is unfortunately the point where I need to ask your help. Prototyping those things and then making PCBs and testing them and making a version 2, version 3, version 4, whatever, does cost a lot of money. And currently, with the pandemic going on, money is a bit tight in the Null Island Space Agency. So you find ways of helping me out financially at the Null Island Space Agency website. For one thing, I have an online shop thingy where you can buy t-shirts and mugs and socks and whatever with the Null Island logo, and I'm working on other shirts as well. And you can donate to me via PayPal, and I'm currently also working on a Patreon thingamajig, because that really helps me out. One prototype board currently with multiple iterations, it's easily for me €200 before I get a working version. And then I need to test it, and if I have a problem, I need to make another one, and so on and so forth. So If you're interested in helping me out, I would really appreciate it, because as I said, I'm releasing everything open source, open hardware, so really donations is the only thing that can help me speed up making more stuff, because currently I can only do a prototype, one prototype a month, maybe every other month if I'm lucky. So please help. Okay, that's it. Thanks for watching, and hopefully next year we can meet in person when this pandemic thingy is finally over. Bye!